Hello, my Trig lovelies. Welcome to Miss Calgill's virtual Trig class. So this week I'm going to start calling everything from this point on quarter 4. So this is quarter 4, week 1, and we're going to do a real quick determinants review. Next week we'll dive into some new stuff. So I've got some 2x2 determinants to review and have a new method for finding the determinant of a 3x3 that I'm going to teach y'all, and we'll see how this goes. So hopefully you were able to bring your math notebook home. I know things were a little bit crazy and you may not have been able to grab things like that from school yet. So if you have another notebook at home that you can use, please take notes. We're going to still keep up with like a real short weekly quiz, and I want you to be able to use your notes on those quizzes still. So let's talk about determinants. So determinants can only be found for square matrices. Can only be found for square matrices. And square just means the dimensions are the same, so like a 2x2 or a 3x3, etc. Once we get up to like 4x4, 5x5, we don't tend to do those by hand, so we're only going to go over doing 2x2 and 3x3 by hand. So 2x2, we'll start there. So if we have a basic 2x2 matrix, let's say it's just letters right now, A, B, C, D. This is how we write the matrix. If I'm saying, hey, find the determinant, then I use what looks like the absolute value bars instead of the brackets. So if you see it written like A, B, C, D with the straight bars, this means find the determinant. So to find the determinant, we have a pretty simple formula to remember for this one. So we've got down diagonals and up diagonals. And the way I remember this is it's backwards to what I think it's going to be. Add the downs, or keep them positive, and subtract the ups. So I think of down as subtraction. That's why I say it's the opposite, and up would be addition. So add the down, so it's backwards. Subtract the ups, so it's backwards. Alright, so if I am doing this, I'm going to start with my downs. So that's going to be A times D. And add is also positive, so this is just going to stay positive. And then subtract my ups, minus C times B. So that's our basic formula. If any point I'm going a little fast, make sure you just pause the video. It'll be easier to just copy down what I'm writing if you just pause it from time to time. And I'm going to trust that you guys know when you need to pause it, and I don't need to remind you. Okay, so let's look at an example using some numbers. So let's say here's your matrix. 1, 2, 3, 4, keep it simple. And I say find the determinant. So I'm just going to follow my same little formula here. I'm going to multiply these two. So that's 1 times 4. Keep that positive, and then I'm going to subtract the other diagonal, the up diagonal. So that's 3 times 2. And order does matter. Which one you subtract and which one you add will change your answer. So make sure we keep it the same direction. So then 1 times 4 is 4, and then 3 times 2 is 6. So the determinant of this matrix is -2. I know these look like They're absolute value bars, and absolute value is always positive, but it only looks like the absolute value bar. I'm not actually saying, hey, find the absolute value. So we can have a negative determinant. Okay, I'm going to move the screen around and do one more 2x2 example, and then we'll get into some 3x3s and learn a new method for that. So I'm going to say find the determinant of this matrix 1, negative 4, 0, 3. So same process, 1 times 3 minus 0 times negative 4. Okay, 1 times 3 is 3 minus 0. So the determinant for this one is just plain old 3. Okay, let's look at this new system for finding the determinant of a 3x3. So I'm going to move over to some empty space. And let's do a 3x3 determinant. So I'm just going to dive in and start with a matrix, not worry about throwing the letters and doing the formula first, because we've seen that before, but I'm going to teach you a new method. So the matrix that I'm going to ask you to find the determinant of is this one. 5, 0, 2, negative 2, 3, 0, 1, negative 1, 7. So if you struggle with keeping things lined up and neat, this method is going to be much harder. So if you have graph paper, please use that for this new method that I'm going to show you. It's going to make your life a lot easier. So the way we get this set up is I'm going to rewrite this matrix, but without any brackets or bars around it, and I'm going to copy the first 2 columns down. If you look back at our formula that we worked with before all the craziness happened before the break, you'll see the method that I'm about to use will give you the same result because you're ending up multiplying the same numbers. But this may be an easier method to remember for some people. So that's why I'm going to teach you a new one. So 5, 0, 2, just copying the matrix down the way it's already written. Negative 2, 3, 0, 1, negative 1, 7. Then I'm going to rewrite the first 2 columns in the same order. 5, 0, 2, negative 2, 3, 0. So remember, we're going to add the downs and subtract the ups. So we start with our down diagonals. So I'm going to start with my down diagonal. This one right here says 5 times 3 times 7. And we add all the down diagonals. So plus negative 2 times negative 1 times 2. Add the down diagonals because there's one more. And you only worry about the full down diagonals. So there's only going to be 3 that I add here and 3 that I subtract on the other side. So 1 times 0 times 0. Now I'm going to do the up. So I'm going to subtract. I'm running out of space, so I'm going to do it on the next line. So minus my up diagonals. So this first one looks like it's 2 times 3 times 1 minus 0 times negative 1 times 5 minus 7 times 0 times negative 2. I actually like it when there's zeros because those terms go away. So let's simplify. 5 times 3 times 7. Let's get some more space to write here. So, like I said, 5 times 3 times 7 is going to give me 105 plus negative 2 times negative 1 times 2 is going to give me a positive 4 plus 1 times 0 is 0. Now let's do the ones in red. So 2 times 3 times 1 is going to give me 6, so minus 6. And then 0 times negative 1 times 5 is going to be a 0. 7 times 0 times negative 2 is also 0. So these three together should give me 109 minus these three together is going to be just 6. So 109 minus 6 tells me the determinant of this is 103. So give that a try on your work that I'm going to post for you to try. And if you have any questions or know that something didn't make sense, just write your questions down for the next time you come to Zoom or send me an email.